Mathematics is made easy, no more fear. Target online class, we got you. Wherever you want to from, we got what you need. Target online class.
Good day, viewers all over the world. You are welcome to Toidel online class. Today we want to continue with the concept introduction. So I've actually introduced this in 2 of our videos. So we want to take examples on the introduction for today. So we can have evaluate the following. So we can have evaluate the following. We can have question like that. A, the first one, where we have integral s cube dx. Then B, we can have integral s raised to the power 5 all over 2 dx. And C, we have integral s raised to the power 5 plus 3 dx. So let's take, this is example 1. Let's take this as the first example. So how do we integrate the following? Well, the question says integrate the following. So what do we do if we have what we have on the board? Now when I did the introduction, I said that if you have, there are 2 types of integration, definite integral and indefinite integral. In this case now, all this example, they are example under indefinite integral because there is no boundary. You don't have upper and lower bound. Like the first one where we have integral s cubed dx. How do we integrate this? So if you want to, this is a polynomial function. If you want to integrate this now, just write s cubed. So you add 1 to this, all over 3 plus 1. Whatever you have as the power will be the denominator. Then plus arbitrary constant. I said if whenever you integrate, you put arbitrary constant. Then here we are going to have s raised to the power 4 all over 4 plus arbitrary constant as the final answer. So that will be the final answer. That will be the final answer. So we take the second one. The second one, B, where we have integral s raised to the power 5 all over 2 dx. So how do we integrate this? This will be s raised to the power 5 all over 2 plus 1 all over 5 all over 2 plus 1 plus arbitrary constant. Whenever we integrate, we must add arbitrary constant to it. But under definite integral, where we have bound, lower and upper bound, we don't need to add that because at the end of the day, it's going to cancel out. So what is 5? 5 all over 2 plus 1. That should be that will be 7 all over 2 because this is 2.5. That will be 3.5. So we are going to have s raised to the power 7 all over 2 all over 7 all over 2 plus arbitrary constant. Then the denominator where we have 7 over 2. That simply means that everything divided by 7 over 2. If I take if I rewrite that, I'm going to have, at the end of the day, I'm going to have 2 s raised to the power 7 all over 2 all over 7 plus arbitrary constant as my final answer. So this will be the final answer there. Yeah, this is what we get. That's what we get. So we can go ahead and solve and integrate the third question under example 1. The third question, C, where we have integral s raised to the power 5 plus 3 all dx. You can break it down. You can split it. So integration is linear. I can say integral s raised to the power 5 dx plus integral 3 dx. So at the end of the day, you are going to have, when you integrate this, you have s raised to the power 6 because it will be 5 plus 1 all over 6 plus, when you integrate a constant, you add x to it because we can bring out the 3. So integration of dx is x. So plus 3x plus arbitrary constant. And that is what you are going to get. That's what we are going to get there. So under integration, indefinite integral, you should take note that we must put arbitrary constants. It is compulsory to put arbitrary constants when you are integrating indefinite integral. So let's take another example. Let's take another example, example 2. You have to integrate the following. If we have something like integral s raised to the power 4 plus s raised to the power 3 minus 4x all over s squared all into bracket dx. Then another question where we have integral x plus 5 into bracket 3x minus 2 dx. Then we can take, okay, let's do this first too. Then we'll go ahead and take another, the last example. So all these questions, they're actually polynomial functions. These are polynomial functions. They are polynomial functions. So, and we know what to do. So in this case now, we start with the first one, A, where we have integral x raised to power 4 plus 3x cubed minus 4x, everything raised to power x squared dx. So in this case now, it depends on how you want to approach it. I might decide to divide through by x squared. I can do that. I'll just divide through by x squared. Then if I do that, I'm going to get integral s squared s2 s squared divided by s raised by 4. It will reduce this to plus 3x. Then here, I'm going to have minus 4 all over x, everything into bracket dx. Then if I integrate the first one, if I integrate s cubed, s squared, I'm going to have s2 plus 1 all over, that's s cubed all over 3. That's what I'm going to get. Plus, if I integrate the second one, there's 1 here, 1 plus 1, that is 2. So I'm going to have 3s squared all over 2 minus 4. You know, when you check the table that I gave in one of my videos, I said the integral 1 all over x is equal to in x. That will be in x. Then if we bring out 4 here, we're going to have integral 1 all over x. That will be 4 in x plus arbitrary constant. And that is what we are going to get as the answer. That's what we are going to get as the answer. So please check that integral table. So whenever you want to differentiate the reciprocal of x is in x, and that's what we are going to get. So we don't go to this second one, this second example. We go to this second example. So let's undo this second example where we have integral x plus 5, 3x minus 2 dx. So how do we integrate this? That's what we want to do. You know, it's a factor. This is a factor. We have 2 factors there. So how do we integrate this? It depends on how you want to approach it. You might decide to first expand what you have before you do the integration, or we can use. So let me just expand. If I expand this, I'm going to get 3x squared minus 2x plus 15x minus 10 dx. So if I simplify further, I'm going to have 3x squared, 15 minus, that will be plus 13x minus 10 dx. So at this point now, I will just integrate separately. I can do it directly, but I can say 3x squared dx because integration is linear, plus integral 13x dx minus 10 integral and minus integral 10 dx. So what do I get here? If I integrate this, I'm going to have 3x 2 plus 1, that will be 3 over 3. Plus, if I integrate this, I'm going to have 13x squared all over 2 minus 10x plus arbitrary constant. If you integrate a constant, you add arbitrary constant to it. And of course, you know that the reverse is the case when it's differentiation. When you differentiate a constant, you get 0. So the final step will just be 3 can take care of 3. I'm going to have s cubed. S cubed, yes, s cubed. I will have s cubed here plus 13 all over 2 s squared minus 10x plus arbitrary constant. And that is what we are going to get. So let's take one more example, probably under trigonometrical functions. Let's take one more example under trigonometrical functions. Example 3, where we have integrate the integral of sine x minus 5 cos x dx. That's what I'm going to get. We have. So how do we integrate this? How do we integrate this? Of course, integration of sine. Integration of sine is cos. So I can split this and say this same thing as integral sine x dx minus 5 can come out integral cos x dx. So what is the integration of sine? Whenever we integrate sine, it's going to give us minus cos. This will be minus cos x. Then minus 5 multiplied by, what is integral of cos? Integral of cos is sine. So that will be sine x plus arbitrary constant. Then from there, I'm going to have minus cos x minus 5 sine x plus arbitrary constant as the final answer. So we can also have integral. There are so many functions. At least we are going to consider about 6. So this the example I gave today is just under polynomial and trigonometric functions. We can have question under exponential functions. We can have it under we can have it under hyperbolic functions. So we can have question under so many functions. So I'd love to stop here because of our time. In our next class, we are going to be specific. We'll be taking integration by parts, by partial fraction, by substitution. We're going to break integration down to what we can actually get. Thank you for listening, and God bless you.
Mathematics made easy, no more fear. Target online class, we got you. Wherever you want it from, we got what you need. Target online class.